Hi everyone, today's topic is process. We are from Sri Vishnu Engineering College for Women, presented by B. Divyashree 22B01A0517, G. Ashrita 22B01A0539, under the guidance of Dr. N. Prasad, PhD, Associate Professor, Department of CSC, SPEC.
First, we will learn about what is meant by process. A process is basically a program in execution. The execution of the process must progress in a sequence fashion. A process is defined as an entity which represents the basic unit of the work to be implemented in the system. To input in a simple terms, we write our computer programs in a text files. And when you execute this program, it will become a process which perform all the tasks mentioned in the program. And when a program is loaded into a memory and it becomes a process, it can be divided into four sections. The first one is stack, heap, text, and the last one is data. The following images shows and simplified layers of the process inside the main memory.
We already seen about the process. In the process, there is a components in so that we will discuss about the components and their descriptions. First one, stack. The process stack contains the temporary data such as a method, function, parameters, return address, and local variable. Second one, heap. This is dynamically allocated memory to the process during its runtime. Next, third one is states. This indicates the current activity represented by the value of program counter and the content of the process registers. Fourth one, the last one, data. The second selection contains the global and static variables. Let us see the representation of a process like stack and heap and data sets in a process.
Our next topic is about process of life cycle. When the process executes, it passes through different states. These states may differ in different operating systems. And moreover, the names of the states are also not standardized. In general, the process can have one of the following five states at a time.
Let us see the states of the process. First, the states and their description. First state is start. This is the initial state when a process is first started and created. Second one, ready state. The process is waiting to be assigned to a processor. Ready processor are waiting to have the processor allocated to them by operating system so that they can run. Process may come into the in this state after start state or while running it by but interpreted by the scheduling to assign CPU to some other process. Third one is running state. Once the process has been assigned to process by OS scheduler, the process state is set to running and the processor executes its instructions. Fourth state is waiting state. Process moves into the wait state if needs to wait for a resource, such as waiting for user input or waiting for a file to become available. Fifth one is terminated or exit state. Once the process finishes it execution or it is terminated by the operating system, it is moved to the terminated state where it waits to be removed from the main memory. Let's see the graphical representation of the states of the graph.
Now let us discuss about process control block. A process control block is a data structure maintained by an operating system for every process. The PCB is defined by an integer process ID. A PC keeps all the information needed to keep track of a process as listed below.
In the operating system, there are 10 process scheduling block and its data as given in the table. Number 1, process state. The current state of process, whether it is ready, running, waiting, or whatever state. Second one, process privilege. This is required to allow or disallow access to system resource. Third one, process ID, unique identification for each of the process in the operating system. Fourth one, pointer, a pointer to parent process. Fifth one, program counter. Program counter is pointer to the address of next instruction to be executed for this process. Seventh one, CPU scheduling information. In this, process priority and other scheduling information which is required to the scheduler the schedule the process. Eighth one, memory management information. This includes the information of page table, memory limits, segment table, depending on memory used by operating system. Ninth one, accounting information. This includes the amount of CPU used for process execution, time limits, execution ID, etc. Tenth one, input output state information. This include list of input-output device allocation to process. Here is the architecture of PCB is completely depend on operating system and may contain different information in the different operating system. Here is the simplified diagram of PCB. At the top of the state, there is a process ID. Every process has their its own ID. The PCB is maintained for a process throughout its lifetime and it is deleted once the process terminated.
Now let us see about process scheduling in an operating system. The process scheduling is an activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. Process scheduling is an essential part of multi-programming operating systems. Such operating systems allow more than one process to be loaded into the executable memory at a time, and loaded process trace the CPU using time multiplexing. Now let us see the categories of scheduling. Mostly there are two categories of scheduling. The first one is non-primitive type of scheduling. In this non-primitive type, the resources can't be taken from a process until process completes execution. The switching of resources occurs when the running process terminates and as well as moves to the waiting state. And the next type is primitive. In this primitive type, the OS allocates the resources to a process for a fixed amount of time. During resources allocation, the process switches from running state to the ready state. or else from waiting state to the ready state. This switching occurs as the CPU may give priority to other processes and replace the process with higher priority within the running process. Now let us discuss about process scheduling queues. In these queues, the OS maintains all the process control blocks in the process scheduling queues. The OS maintains a separate queue for which the process states and PCBs of all process in the same execution are placed in the queues. When the state of process is changed, its PCB is unlinked from its current queue and it moves to its new state queue. The operating system maintains the following important process scheduling queues.
Here is some process scheduling queues as given that first one job queue. This queue keeps all the system ready queue. The queue keeps a set of process residing in main memory ready and waiting to execute. A process is always put in this queue, device queue. The process which are blocked due to unavailability of an input-output device constitute this queue. Let us see the architecture of the process scheduling queue as given here. The OS can use different policies to manage each queue, FIFO, round robin, priority, etc. The OS scheduler determines how to move process between the ready and run queue, which can only have one entry per processor core on the system. In the above diagram, it has been managed with the CPU two-state process model. Two-state process model refers to running and non-running state which are let us see the process refining, running and not running. Here, first one, running. When a new process is created, it enters into the system as in running state. Second one, not running. Process that are not running are kept in the queue, means waiting for their turn to execute. Each entry in the queue is pointer to particular process. Queue is implemented by using linked list. Use a dispatcher is as follows. When a process is interpreted, that process is transferred into waiting queue. If the process has completed or aborted, the process is discarded. In either case, the dispatcher then selects a process for the queue to execute. Finally, thank you for explaining the process concept.